Hello again, this is Dr. Armand bringing you another exciting virtual video on the experimental procedure for experiment 1, methods of inquiry and measurement, part 2. So in this video, we'll be looking at the procedural aspects of part 2 of experiment 1, which involves the chemical properties of different types of substances. So sit back, relax, and enjoy the show. So the chemical properties part of experiment 1 can be divided into 4 parts. So I'm going to show you the first 2 parts and then show you the latter 2 parts and group them in those categories. So A and B, we'll look at A and B first, and then C and D. So with part 2A, we're looking at the chemical properties of different salt solutions. So what you're going to do is you're going to have different salt solutions. You're going to mix them together and observe what happens. And so for the ones that you do see a sign that a chemical reaction has occurred, you may want to use something called the solubility rules to help analyze your results. And so make sure you watch the Prelab video for experiment 1, where I go more into detail on how to analyze the results from the experiment. So that's 2A. We're looking at the chemical properties of salt solutions. In 2B, we're looking at the chemical properties of metals with an acid. So you're going to be taking a strip of metal, reacting it with an acid, and observing what's occurring. Does it react? Does it not react? And when you're discussing or analyzing the results of part 2B, you need to refer to the activity series to help you investigate why certain metals react and why certain metals do not react. Now, the metals that react with the acid, they produce a salt and hydrogen gas. So you should see the evolution of gas when it's reacting with an acid. And the acid we're going to use is hydrochloric acid. So now we're going to show you the process involved with this part of the lab. So this is part 1 of the chemicals property aspect of experiment 1. And so what you're going to be using, you're going to be using a cell well plate. And we have here different sodium salt solutions. And so here we have 4 different sodium salt solutions: sodium chloride, sodium sulfide, sodium hydroxide, and sodium carbonate. And we're going to react them with different types of solutions. Let me go back a little bit. We're going to react them with silver nitrate, copper nitrate, zinc nitrate, magnesium nitrate. Now for this example here, we're going to be using cobalt 2 nitrate. So this cobalt 2 nitrate is just for this example in this video of how you will conduct this experiment with the other solutions. So you're going to be using different solutions. You're going to put drops of each solution into it. So here we have our sodium solutions already in the cell well plate. We're going to add the cobalt 2 nitrate solution to each one and observe what happens. So when we add the cobalt 2 nitrate solution to sodium chloride, nothing happens. When we add the cobalt 2 nitrate solution to sodium sulfide, you notice that we form a black precipitate. When we take cobalt 2 nitrate and react it with sodium hydroxide, we form a dark blue precipitate. And when we add it to sodium carbonate, we see a pink, or magenta color precipitate. Let's go through that one more time. And so what you'll do is, as you add each one of these solutions to your sodium salt solutions, you're going to observe what occurs when you mix the two solutions. So in this set of examples with cobalt 2 nitrate, the sodium sulfide, the sodium hydroxide, and sodium carbonate reacted with the cobalt 2 nitrate because we had a new product form. And so you want to ask yourself, do these results make sense? So I'll help you analyze two of these so you can kind of get the idea of how you go about analyzing these results. So for example, in the first one, we have cobalt 2 nitrate plus sodium chloride. So these are undergoing what are called double displacement reactions. So we flip the two cations, we get two new compounds. And here you want to ask yourself, are these products shown here soluble or insoluble? And so you have to refer to the solubility rules. And what you'll notice is any salt with sodium in it is soluble. So this is soluble. And chlorides, you'll see based on the solubility rules that cobalt 2 chloride is soluble as well. So since both products are soluble, no reaction should have occurred. And this is correct because we did not observe a reaction when we mix cobalt 2 nitrate and sodium chloride. We'll look at one other one. Here we have cobalt 2 nitrate plus sodium sulfide. Again, we're going to take the two cations, make two new compounds. Again, sodium nitrate is soluble, so it won't react or it won't form a precipitate. So this is soluble. But if you look at your solubility rules for sulfides, cobalt 2 sulfide is a precipitate. So this is insoluble. So the experiment does correlate to the theory that when you take cobalt 2 nitrate and sodium sulfide, mix them together, you get a precipitate, which is cobalt 2 sulfide. So the theory correlates to what you observe in the experiment. And so this is how you will analyze the results. And so you'll repeat this for the silver nitrate, copper 2 nitrate, zinc nitrate, magnesium nitrate, and iron 3 nitrate. You'll mix these with the different sodium chloride solutions. So you'll go ahead and put the sodium salt solutions, you'll put them in all the cell wall plates, and then you'll add the solutions up here and observe what happens. So the next part of the lab involves reacting an acid with different metals. And so the metals you're going to use are zinc, copper, magnesium, and silver. So you're going to add these to hydrochloric acid and observe what happens. And so for this example, I'm going to use nickel. So nickel is this shiny piece of metal here. So I'm going to take this piece of metal, a little small piece, and drop it into the HCl solution and observe what happens. So I pick up the piece and drop it into the HCl solution. And so what you're going to be looking for here is the formation of hydrogen gas, which will see little bubbles of gas form around the nickel wire. Now, don't be alarmed if this takes a couple of minutes. It may not happen right off, right as you add it. So you may have to wait 5 or 10 minutes and come back and observe it further. So here you can see that it hasn't reacted yet, so you may have to wait for a little while for the reaction to start. And so this is something you should record in your observations, that either A, it takes a long time for the reaction to occur, or B, after 10, 15, 20 minutes, no reaction was observed. So the last two parts of the chemical properties section of experiment 1 deal with the chemical properties of different types of carbonates when reacted with an acid, and also reacting different metals with different types of metal solutions. Now, when you're filling out this table, please bear in mind that if you take zinc and react it with zinc nitrate, there shouldn't be anything. So you don't have to fill this one in, this one in, this one in, or this one in, because it shouldn't react with itself. If it does, there's something wrong with your experiment. So zinc should not react with zinc nitrate. For the carbonates, you're going to use sodium, potassium, magnesium, and calcium carbonate, react them with an acid, HCl, and observe what happens. And hopefully, by the observations, you can determine which one reacts the most vigorously and which one does not. So what you're going to do is you're going to take some of your powder carbonate, the solid carbonate, add it to HCl, and observe what happens. And when a carbonate reacts with an acid, it produces a gas, CO2, salt, and water as products. So you're going to write those observations in your notebook. So for part 3, we have different carbonates. So for this example, we're going to use lithium carbonate. In the lab, you're going to be using sodium carbonate, potassium carbonate, calcium carbonate, and magnesium carbonate. And so we're going to add some lithium carbonate to the HCl and observe what happens. And you don't need much lithium, much of the carbonate, just very little, like almost a pea size. Now here we're going to show you that if you try to dissolve it in water and then add it to the HCl, it may or may not react depending on the concentration. So here we're showing you what happens when you dissolve it in water. And you see we don't get much of a reaction. So it's best not to dissolve this in water first. It's best to it's best just to take the powder and add it directly to the HCl. So it's very hard to observe any type of reaction when you try to dissolve the lithium carbonate first in water. So now what we're going to do is we're going to add the lithium carbonate solid directly to the HCl, and you see it very quickly reacts with the HCl. So this is what you want to do with the sodium, potassium, magnesium, and calcium carbonate. Is you want to take a very small amount of the powder, add it to the HCl, and observe, record any observations that you see. Now the last part, part 4, we're taking different metals and reacting them with different metal solutions. So on this part, your TA will assign you one of the metals and you'll react it with the different metal solutions for part 4. So we'll be using zinc nitrate, magnesium nitrate, silver nitrate, copper nitrate, and iron nitrate, and reacting different metals with them. And so for this example, I'm just going to show you nickel because we don't want to use a metal that is what you're going to be using in lab. So down at the bottom, we have small pieces of nickel that we're going to add to the different solutions. So again, in the lab, your TA will assign you one of the different metals to put in each solution and to observe or record any observations that you notice. So again, we're using a cell well plate. We have the solutions in the respected cell wells with the labeling. And now we're going to take a piece of nickel and add it to each solution. So we take a piece of nickel, add it to silver nitrate solution. And again, you may have to come back after 5 minutes, after 10 minutes, 15 minutes, and see if there's any reaction occurring. Then we take the nickel, add it to copper 2 nitrate. You can see here it kind of quickly turns a black color, which may indicate a reaction is occurring. Next, we're going to add one to the zinc nitrate solution. You got to be careful because sometimes the metal sticks to the forceps. Next, we're going to take one and add it to the iron nitrate solution. Again, these are small pieces of metal. And you're going to watch and try to observe any indication that a reaction is occurring. And then, of course, in the magnesium nitrate solution. So that's how we do the last part of the experiment. We're going to be adding small pieces of metal to the different metal solutions and observing any signs that a chemical reaction has occurred. Now, the last bit of this video shows how to properly dispose of these chemicals in these cell well plates at the end of lab. So make sure you watch this. This is very important. So what you want to do is you want to take your cell well plates using a beaker. You want to rinse it with water, DI water, to clean out the cell well plate. So very gently wash it with water, rinse out each of the cell wells that had something in them. And you want to collect this into a waste beaker. So this is from part A of the chemical properties. And you can do this at your lab bench. So now it's clean. Now for part 2, which had the pieces of metal, you want to first take out the piece of metal from the cell well plate, put it in a different beaker because the solid pieces and the aqueous solution go into 2 separate waste containers. Then rinse out your cell well plate with DI water again. For part 3, you're going to do the same thing. You're going to rinse it with DI water. the cell well plate. Again, all the solutions should be collected in one waste beaker. All the pieces of metal should be collected in the another waste beaker. So in part 4, you have to remove all the pieces of metal from each cell well plate and put it in the solid, your solid waste beaker. Then make sure you rinse the cell well plates with the DI water. Because again, the aqueous solutions go in one waste container, the metal solids go in another waste container. So now that you've cleaned all the cell well plates, now you take the beakers to the waste containers to dispose of the chemical waste. So that's the aqueous waste, and that's the smaller beaker has the metal pieces in it. So the one with the aqueous waste goes in the waste container labeled metal/ion aqueous waste. So make sure you pour that into this waste container. So your aqueous waste goes into that waste container. Make sure you rinse all the beaker out to get all the residual waste. And then with the metal pieces, they go into the solid waste container. So this is where the solids get disposed of. It's kind of like a small chemical trash bag. Solid waste. So the white container is for the solid waste. The glass bottle is for the aqueous waste. So that concludes part 2, the chemical properties of experiment 1, methods of inquiry and measurement. I hope this video was informative and you were able to understand the different aspects of the procedure for this experiment. Until next time, Dr. Armand signing off.